Right, so welcome to this MBOR EBI training webinar that's going to look at the MolStar web tool for visualizing 3D molecular structures. My name is James Tolchard and I'm a data curator here at PDBe Europe. Now in the next few slides, I'll outline the topics the talk will cover, but feel free to ask questions at any time by the chat box and your viewers. We'll save answering them to the end. But I'm also going to be joined by Mandar Deshpande, a developer here at PDBe, and between us, hopefully we'll be able to answer your questions. Of course, you can always ask questions or contact us specifically at PDBe via email or our social media channels as well. Right, so I'm talking to you today from the PDBe in Europe, placed just outside of Cambridge in the UK. We are one of the 4 sites that comprise the core PDBe archive, along with RCSB and the BMRB in America and PDBJ in Japan. And as such, we help to collect, curate, store and disseminate atomic structure information to users all over the world. We also aim to provide outreach activities to the public and training materials to the scientific community. And this webinar is one such example. Now, here is the outline for the talk. I'll firstly introduce MolStar and its development, before showing you the basic use and visual look and feel of MolStar. And I'll then move on to show you how you can look at volume data, whether it be by Xray or Xray Crystallography or EM. And we'll finish up by looking at ligands and visualizing annotation data before briefly discussing a few of the developer-related aspects that have been kept in mind during the development of MolStar. So, to introduce MolStar, I'll assume all of you are at least familiar with the principle of molecular visualization and are probably aware of a few existing tools already. Perhaps the most well-known software programs are the desktop-based ones, such as PyMol or Qt, that is, ones that are locally installed. Now, these often have powerful features such as elements of refinement or docking, but lack full web integration. On the other hand, there are a number of web-based tools such as JSMod or NGL, and whilst this can be embedded online, they often have very specific functionality, and without the power of local hardware, they can struggle to display larger structures and volume data. Therefore, it was with the idea of resolving these 2 conflicts that MolStar was developed, to provide a molecular viewer that was easy to use and suitable for embedding online content, but which could also be used to explore aspects which are typically more computationally demanding. This last challenge was tackled from a few directions, and now, as I'll show later, we also host specific data servers which can be used to serve both coordinate and volume data in a very precise manner, so as to be efficient with data transfer, data passing, and data processing as possible. I'm pleased to say that the MolStar development has been and continues to be a collaborative effort. From the beginning, MolStar has been co-developed between David Senno of PDBe and SciTech and Alex Rose at the RCSB US Protein Data Bank. And then with the scope for site-specific integration, our own Mandar Deshpande has joined the effort with a view to incorporating MolStar into PDBe's online content. In terms of features, MolStar was designed to provide ready access to the most common visualization aspects, like molecular representation and coloring, as well as overlays of biological assemblies or validation scores, and for comparing atomic coordinates to their corresponding volume data. There is, of course, the ability to pull structures directly from the PDBe with an entry's accession code, and you can load local structures for visualization as well. There's also many advanced options to dig through, such as occlusion and other lighting effects. And thanks to the magic of WebGL, the images you create can be exported in high quality in next to no time, without costly operations such as ray tracing. Lastly, it's worth quickly highlighting that I've actually been able to embed MolStar directly into today's presentation using an iframe component on the slides.com presentation website. Technically, I couldn't find a way to do so with Microsoft PowerPoint or Google Slides. However, I thought it worth mentioning quickly, as in the past, I've spent a lot of time looking at ways of incorporating 3D structural data into my talks. So, let's look at the basic usage of MolStar and show you how to load a structure directly from a PDBe entry page. But just before, let's briefly run through the controls. So depending on whether you're using a mouse or a touchscreen device, The controls are as follows. To select and rotate molecules, simply left click and drag, or one finger hold and drag. To move or translate a selection, just right click and drag, or two finger hold and drag. To zoom in on a selection, either use the scroll wheel or two finger pinch. Two finger scrolling to zoom also works on my laptop trackpad. And for slabbing, either use the scroll wheel with the shift key held down or three finger holding and dragging on a touch device. Okay, so when landing on a typical entry page, you would immediately have a 3D visualization link on the right-hand side. Similar links are available directly from the search pages as well. And now you can see after clicking this, the Molestar viewer will open and the central section will show you your molecule of interest. We also have the basic settings on the right-hand side and the control bar at the top. To quickly go through the control bar, we have from left to right, a help icon that can show the mouse and touch controls, a settings cog that expands into advanced options where we can change many settings like those to do with image rendering, an image snapshot tool to take quick snapshots of the viewer and download them to your downloads folder, the control icon which toggles basic settings on and off, a toggle expanded full screen icon, which is in effect in this viewer now, and lastly, a reset camera button, which is self-explanatory. Now the controls I previously mentioned work here, and hopefully you can see the speed at which I can easily move around the structure, whether it be by rotating, translating, moving around the structure, zooming in, and then when clicking on a specific area of the protein, I can also hold shift and scroll and change the slabbing as well. Now, in terms of the most readily accessible basic visualization settings, you can find these on the right-hand side, where each molecule type will have specific options. Under polymer properties, you can easily edit the visualization style. So for example, from cartoon, we can change this to space filling atoms and click update to see the change immediately. You can also select from many predefined color themes. For example, here we can change to residue name. And you can further alter the color scheme from the next drop-down box should you wish. Lastly, should you actually hover the mouse over certain areas of the structure or tap with the touchscreen device, you will get selection information about this part of the protein in the tooltip shown along the bottom of the screen. Should you wish, you can also change the granularity of the selection in the advanced options, where we can alter the selection mode, for example, distinct chains. Now, if I hide that advanced option, you should be able to see that I can now select distinct chains entirely, and that this information is also presented in the tooltip below. Of course, feel free to experiment with Molestar on the PDBe website throughout the webinar. But now, in this section, we will cover how to look at and interpret volume data with Molestar. Firstly, for Xray crystallography. With Molestar open, we can find map options in the basic settings pane on the right-hand side of the viewer. And this would appear for all Xray entries. But even without changing any options, just left-clicking on the structure will actually bring up the 2FO-FC and FO-FC emission maps on top of the structure. If you're not familiar with these, simply put, the 2FO-FC map should highlight the density into which the model is being built. And the emission map should highlight any extra density that either wasn't modeled into, shown here in green, or extra bits of model which are not well described by the data, shown in red. Now, here is another example of that in practice. So again, if we navigate from an entry page using our 3D visualization link, once loaded, we can see that by clicking on a part of the protein, an actual part of the protein, we automatically get a slab zoom to that residue, and the relevant section of the density map is fetched and overlaid on the structure. This is an example of Molestar using the PDBe volume server, and you should be able to make out, especially if I zoom out now, that we are in fact only looking at a small section of the map. This is actually quite a nice entry, and if I can find them, where's the one here? Hopefully you should be able to clearly make out the density that nicely describes these iron coordinated heaves. Now there seems to be a standard level of noise in the red and green emit maps here. However, should you want to investigate these further, there's also a facility on the right-hand side to drop the visual threshold for any of the maps. Also, by clicking on the map names, you can also change the color and representation, as well as the opacity of the maps. And lastly, if I scroll down, hopefully this will load quickly, you can also change which sections of the map are visible at any one time. So for example, now our view is defined as around interaction, which is then where I clicked on the model. But should I change it to whole structure and click update, we're now sourcing the entire map for the whole asymmetric unit. And hopefully if I slab out fully, you should be able to see that that's indeed what we're visualizing in our totally online viewer. Now, okay, moving on. In this section, I'll show how we can start to analyze EM map data. So historically speaking, visualizing EM data has required quite large data transfers. Other tools, for example, would previously ask you to download the map files to your local machine. However, with Molestar, any EM entry with an associated map can be quickly visualized totally online. This firstly takes advantage of the volume server, as I previously mentioned for the electron density maps. However, we also improve the speed of map visualization for EM data by actively downsampling the maps when using a low zoom level. This way we can be efficient with the data we need to serve and process, and the user can hopefully appreciate map data at any level without any significant lag. Now in this example, we will open Molestar directly from a PDBe search result. So here you can see that on our website, I've free text searched for this entry code 6R7M, the structure of the tobacco mosaic virus capsid. And now directly from the search result, I can launch Molestar again with this 3D visualization link. Now you can instantly see how quickly a version of the whole map has been loaded and visualized. And this is default behavior for any EM entry. On the right-hand side, we can see the map settings. For example, we can toggle hiding and showing, as with many other properties. And by clicking on the EM tab, we can also then change the color and representation of the map the same way we could for the electron density data. Now, in fact, in this part of the demonstration, I'll actually change the polymer color to help clarify things. So under polymer properties, we can change the theme to uniform, and hopefully that will make things a little bit clearer. Now, where are we? Okay, so as with Xray data, we can change the threshold of the map, should we want to. And if we look under the view properties here, we can even change the detail level at which we're observing the map, where in higher tiers are more, contain more information. Now at this level, we can clearly make out, especially if I turn the structure this way, and zoom in again, we can clearly make out the additional volume for which the depositor did not continue to build did not continue to build structure for. But then if we change the view type to around interaction, if we click on an individual or specific part of the protein, we can clean up the view to take a closer look at how the model was precisely fitting the map. And for example, here we can start to see some helical density and perhaps even see some side chains that are well described by the map. Okay, now here I will show you how Molestar can be used to show annotations, including those prepared by the PDBe and those from other bioinformatics services. So what I mean by annotations here are, for example, highlighting the differences between the structure and the asymmetric unit versus the biological quaternary structure, or symmetry partners. I'd like to think that perhaps most of you are familiar with the PDBe's validation reports that we produced both during deposition and alongside our entries online. Now, these have a simple color code from green to red that describes the accumulation of geometric issues at the residue-specific level. And using this information, we can combine it with a coloring scheme for across our protein, so that we can start to visually interrogate our validation metrics from any entry from the PDBe archive. In terms of other tools, we can also put in annotations from services such as PFAM to highlight extra features like protein domains. Now, very quickly, I'll show you these features now for a structure of HSP90 with an inhibitor. At the top of the control pane here, under source, there's my mouse, under source, we can see that the biological assembly is selected by default, and that in this structure, it is a dimer of two distinct protein chains. However, if I choose to show the deposited file, back to source, change the deposited file and click apply, we can see that the dimer was actually built with a symmetry operation, and that the deposited coordinates in the asymmetric unit only describe a monomer. For clarity now, I'll show you that when waters are present, as a molecular type, these also have their own visualization options. And again, for clarity here, I'll just turn them off. But if I pop up again to the annotations pane, I can now choose to show the validation report data and the coloring directly on the protein structure. Now here we can see, perhaps unsurprisingly, that our most dynamic regions, flexible loops, are those which possess the worst geometric scores. And indeed, if we then hover over these specific residues, we're able to see a bit more information about this in the tooltip at the bottom. And here we can see that residue tyrosine 38 has issues in the validation report with respect to atomic clashes, bad bond lengths, and bond angles. Now, in terms of other annotations, if I now turn validation report coloring off and activate domain coloring, I can now start to show annotations from external services. So here, PFAM is showing an example of this histidine kinase domain, or DNA gyrase B. Also for this structure, Interpro, for example, would highlight the different subdivisions of functional families in HSP90. So for example, where are we? Should get some distinct coloring depending upon the Interpro classification. And again, we can see this specifically written out in the tooltip at the bottom. And for CAF, we should hopefully be able to see the structural annotations describing the whole heat shock protein topology. Okay, so moving on from annotations, here I'd like to show how MolStar can be a great way to investigate ligands in specific PDBe entries. For example, when on an entry page where ligands are present, specific links will be available. If you scroll down a little bit here on this entry for P450, these links will be visible for each chemical component. When these are clicked, we're taken to a ligand page and presented firstly with a 2D view of the ligand, which doesn't seem to be working today, but usually it should be a 2D version of the ligand on the left-hand side here, which describes the neighboring protein residues, but also an instance of MolStar on the right-hand side in 3D. Oh, there we go. Now our 2D view is present. If multiple versions of the ligand are in the structure, these can be zoomed to specifically by using the drop-down box at the top to get refreshed visualization for these ligands. Now, in this instance of MolStar on the ligand page, to save space, the right-hand control pane is hidden by default. However, by toggling the expanded view from the top control bar, we can maximize the viewer to take a closer look. Now from here, we can also show all the controls as they were available before, with the toggle controls button. And for X-ray entries like this one, the 2FO-FC and emission maps are shown by default, and you can readily inspect specific ligands for any given entry. Now, in the last interactive section of the talk, I'll describe how Molstar works with other components of the PDBe website to help show correlations between sequence and structure data. So from an entry page, we can also choose to investigate macromolecular entities via the molecule details link. Now you can find this, again, if you scroll a little bit down on the page, under the macromolecular tab. So here we have molecule details. Now on this page, we can see a linear description of the protein chains from N to C terminus, and how different elements such as uniprot sequence or PFAM domain align along it. Calculated features such as validation metrics and secondary structure are also shown, and at the bottom you'll be able to see a 2D secondary structure diagram and another instance of Molstar at the bottom. Now these three panes are actually all tied together behind the scenes, and if you hover over any one feature on any of the three components, you should start to see how you can visually correlate data between the representations to further investigate the system. For example, here, I can again investigate which residues have the worst validation metrics. And if I choose to investigate one in particular by left-clicking, I'll get a zoomed view in the 3D interface Molstar window. Now, this instance of Molstar is very similar to the previous ligand-specific version. Now again, if I click on the toggle full screen icon, I can get a full, that's why I reset the view here, there we go. I can get a full maximized window. And now just to finish, I'd also like to show how you can show different models within a given entry using this example of a solid state NMR entry. So if I open the basic controls, when available, there will also be a model slider under the source pane. If you simply move the slider to a different model number and click apply, we should be able to traverse the ensemble to investigate each individual model. Okay, so I hope I've been able to show some of the core features regarding the use of the Molstar viewer. Another positive aspect to Molstar is that it's being actively improved by multiple developers and has been created with wider use cases and other developers in mind. Therefore, lastly, I'd just like to highlight a few of these points. Firstly, it's simple to embed on any website or indeed presentation, as I hope I've been able to show today. And it also comes alongside extensive documentation, which is available through its GitHub codebase. Then, as you have also seen today, specific instances of Molstar can be tailored to specific use cases. We already have several variants between different PDBe resources, and whilst the core components are lightweight, more complex modules can be loaded individually to help keep data transfer and processing to a minimum. If you already have scripted viewers that you use or implement on your own websites, Molstar was developed alongside a new query language, MolQL, and this can help in the transfer of existing scripts to the Molstar environment. Lastly, Molstar itself is fully open source code, all of which is available through the associated GitHub account. And for a bleeding edge instance of Molstar that packs full functionality from all of the available modules, please head over to molstar.org to have a play. Okay, so this is the end of the talk. Thanks for staying to the end if you're still with us. In conclusion, I hope I've been able to show that Molstar is a fast and simple online molecular viewer with powerful tools for analyzing complex structures. By drawing upon the coordinated links that the PDBe maintain, I hope you can see how Molstar has the potential to readily allow the comparison of structural models to their associated data, and that it does so efficiently with particular regard to speedy visualization of volume maps. Okay, so this is now the end of the talk. And if anyone has any questions, myself and Mandar will be happy to answer them.
Okay, thanks very much, James. We do have time for questions. While you're thinking of questions, just a quick reminder that this is part of our regular Wednesday webinar series, and you can find all the information about upcoming webinars on our PDI training website. which you can see the link for on the screen now. Do remember also to fill in the feedback survey that will launch at the end of the webinar. Okay, let's take a quick look and see if there are questions. And I know there were a couple coming through as we spoke. So there was one question about, can you use scripts, for example, in Python to customize the visualization? Just for the purposes of the recording, Mandar did answer this saying, yes, you can do that. And there is a wiki page that tells you more about how you can do that.
Yeah.
So a question from Nicholas. Is there plans for creating map slabs and then being able to rotate them? This is necessary for EM visualization. And there are real problems with what EMDB is currently using.
Interesting. So I'll make a note of that. I'm not aware of anything in development for map slabbing, but certainly that's something we can look at including. Mm-hmm. Yeah.
So EMDB is also one of the EDI resources and is quite closely linked with PDBe. So that's a perfect question to feed back to.
Exactly. Yes.
Any other questions? Oh, great. Any plans for a desktop app?
So I suppose the quick answer is no. I guess a large fundamental part of North Star, there's an online viewer. I believe should it be applicable, you can load an instance of Molestar in your browser, disconnect from the web should you want, and you can still play around in that viewer. But in terms of being a totally separate desktop application, I don't think that's in the pipeline now.
Okay. And the secondary part of the same question was, what about displaying many frames as NMR data or MD trajectories?
Yes, so as I said, Molestar is being actively developed, and those are on the agenda for upcoming versions. Yeah. Okay,
good to hear. Okay, so if there's any other questions, keep writing them into the chat box. So there's a question about volumetric data and showing protein cavities. Is it possible to display it as a density map?
Interesting. So I'm not familiar with that. What that type of data file would be. If it takes the shape of a typical map format file, then perhaps, yes. I don't think the instances of Molestar on the PDBe website will allow you to upload that and view that, but certainly on the molestar.org bleeding edge instance, that might be a feature that you could play with there.
I guess if you have specific data sets that you are playing with, you can always get in touch with the Molestar team or the PDBe team.
Of course, yeah. And
with specific details about what you're using to find out more about that as well. Another question this afternoon is, how easy is it to port JSML scripts?
So I believe this might be a question from Mandar, but I believe in principle it should be quite simple. So this MolQL language has a translator. What was the question in JSML? Which should help to convert existing scripts into ones which are passable by Molestar. I'm not sure if Mandar's provided an answer, but no, I would say it should be relatively easy, yes.
And so Mandar's just added MolQL do support JMol as well.
Yeah.
And he's provided a link that you can look up to see how you might go about doing that. Are there any other questions for James and Mandar this afternoon? Okay, there don't seem to be any more questions. There are a few thank yous coming through, which is really nice to hear. And I'm going to send a thank you back to you all. Thank you for joining us this afternoon and being quite an interactive audience. And thank you, James, for delivering a very interesting webinar. We hope to see you all again soon.